All right, so thank you for coming to my talk, Modernizing the Enterprise Desktop Application. I'm Oren Novotny, a program manager on the .NET team, and I'm also executive director of the .NET Foundation. Best way to get a hold of me at any time is on Twitter, and I check that probably more than my email. Well, way more than my email. Let me click back, hold on. So if you I'll try to get to questions towards the end of the talk today. And I'll be around all day tomorrow, or most of the afternoon, most of the day tomorrow. But if there's anything I don't get to and there's something that's burning on you and you're like, hey, I'm really trying to move things over, please reach out to me on Twitter and I will do my best to route that to the right person if I can't get to you directly. So, and if we need to take it offline and go deeper over email, we can do that too. But let's go forward. So application modernization often touches upon several areas. We tend to think about it as in terms of code, and I want to use the latest feature. But there's more to modernization than code. It's often part of a larger process that involves some DevOps, involves distribution of the application, telemetry so we can start making more informed decisions about our application, and then certainly modernizing the controls to use the latest of the technology stack so our application is friendly and touch-friendly, accessible, and more available to our users. So we're going to touch upon these over the course of the next hour, and we're going to start with a legacy application. It's a .NET Windows Forms application, .NET framework, that's distributed with ClickOnce to get that out to our fictitious user base here, Contoso. So I switched to the demo machine. Just quick show of hands. How many folks here are using ClickOnce? Good bit? OK. So this won't be entirely unfamiliar to those of you, to the rest of you. ClickOnce is a technology that's been in .NET Framework for quite a long time, where I can install an application from a network share is the most typical place. We don't really distribute this off the internet. And we see an application. This one is a expense reporting app, and nice and colorful, probably more colorful than your typical expense reporting app. Here we have a master details list. I can add a new expense, see existing reports, and see some forms. I can come in, type some information like this is NDC dinner. Let's just say it's a nice dinner, and pick a date, right? This is pretty typical, nothing fancy here. Just and it must give me a description. Steak. There we go. All right. So far, this is your typical line of business app, and we want to see how and what we can do to modernize this, and that's the journey we're going to go on here. So let me just switch back. Oh, wrong button. I think the labels are reversed. There we go. So I'm going to switch back here to, sorry, jumping ahead to my next demo. All right, so .NET Core 3 for desktop. There's been a lot of development over the past year in the .NET Core space, but it really has been only this last period of time where it started to be relevant for the desktop developer. Up until now, .NET Core is focused mainly on web and cloud scenarios, and the desktop has been left out. But in the aim of moving everyone forward and getting all workloads over to .NET Core, we've expanded that support to include the framework in the full UI stack. So WPF and Windows Forms have moved over to .NET Core, and that's where the investment is going to be going forward. It is going to be on .NET Core. And that gives us a huge number of benefits that have been come along with the platform. Things like side-by-side deployments so that you can actually use the latest technology. Just quick show of hands here. How many folks here that are targeting .NET Framework are able to target, say, let's just say, I won't even ask about 4.8. How about 4.7? OK, good. 4.6? Few, OK. Anyone stuck targeting 4.5? I'm sorry. So this has been a key challenge in adopting the latest technology, because .NET Framework is machine-wide. So if you try and you want to use the latest tech, you have to plead with your IT department or your customer's IT department, which may be even more of a challenge, to get the newer version of the framework deployed. And they're hesitant to do that because they're may be changes. There may be breaking changes. We try not to break anything, but when .NET is on close to 1 billion machines, somebody, something, somewhere is going to break. So it is important to test all this stuff, because what might have been a bug fix for a behavioral change or something, one person's bug is another person's behavior they were relying upon. So it may have been technically a correct fix, but it may have invalidated some previously working code, and then we get yelled at. So we've been very reluctant to put any more significant features into .NET Framework, because it's just not a good model of servicing going forward. .NET Core allows us to put multiple versions of the framework on your machine at the same time, and your application will continue running on the version of .NET Core that you targeted and you specified as the developer. So you can also then have side-by-side, Xcopy deployments, entire self-contained deployments. So you don't even have to rely on your IT department or your customer to roll anything out. That's to say, I can publish an application, and all of the files that you need to run it are on the output directory. I can Xcopy that. I can put that on a thumb drive, hand that to somebody, and say run. And they need nothing installed. I can take that further and compile that, and there's a publish option where I can make that into a single exe file. So instead of having 150 files in the output directory, I have one. Single exe file, might be slightly on the larger side, 60 some odd megs. But come on, we joke about the size, but the Facebook app on my iPhone is 200 megs. Like, I don't discount that it is an issue for some people, but in the grand scheme of things, it's probably not where is probably not the blocking scenario, although we are working on making that smaller and increasing options to trim that down going forward. So just you have a number of options there as well. We've also made it easier to enable and access the modern features of Windows 10. So some of the APIs are things like Bluetooth or camera or geolocation are much easier, much more advanced if you use the Windows Runtime APIs. And we've added and released compatibility packs and released packages and the capability to interop with that with .NET Core better than you could in previous areas. And finally, .NET Core is developed completely out in the open. It's open source, so in any of the times you've had issues, and I used to develop Windows Forms applications back in the .NET time period and ever since. I'd hit that bug, I'd step through it, and I'd hit that compiled system.windows.forms.dll, and oops, can't go any further to step into it. Any of you find that? Stepping in, WPF, Windows Forms, get stuck? Say, if only I could step through and see what was going on. Well, now you can. You can, Visual Studio out of the box supports, you can step an F5 straight into framework code, and it will even pull that source code straight off of GitHub, so you don't even have to have checked out the repository ahead of time. So it really enables, you'll see all the variables in the debug window like you're used to. So that can add huge amounts of productivity to your day-to-day. It also means that if there's some issue that you need addressed, that you say, hey, this is broken, or this isn't working, can we fix that? You can submit issues and pull requests and patches, and Microsoft will take them. I know there are people in this room, because I'm looking at some of them, that have submitted contributions that have been merged into .NET Core. I think the number is something like 30% of the contributions to the framework or to .NET Core are coming from the community. It's an awesome number, and I'd love to see that grow. So it is an active area where the community is working together with us to develop the runtime here. To migrate to .NET Core, there's a few steps you would probably want to look at. First thing to start with, it's a good idea, is the .NET Portability Analyzer. So I have links to all these on the resources slide at the end, so I know that some of you may want to take pictures. Go for it, but I do have a slide with all of the links at the end. So the .NET Portability Analyzer will give you a report that, and it scans your code. It does not upload anything to us. It stays everything stays on your machine. It gives you an Excel file that you can use to find if you're using any APIs that may not be supported by .NET Core 3. We support almost everything, but there are a couple of areas that simply aren't there, such as app domains and the WCF server. We've said that that's just out of scope. We're not going to do it. There are better, more modern alternatives for that. So for something like app domains, there's guidance about what you can do instead. And for things like WCF server, the WCF client is there, but for the server, there's an open source project that is working. We've donated some of the code there, and they're working on getting out a new version of the server. So it'll help look and show you some of the problem areas that you may want to take a look at. Then we have a tool that is, I think call it beta. But alpha, beta. If there's issues, we want to hear your feedback. Please file them on the GitHub site, and we'll try and address them. But it will do a best effort to try and pass and convert a lot of the project system and a lot of the stuff over to .NET Core 3 for you. And we'll take a look at that in a few minutes. Super important, test your app. You may say, hey, it compiles. It's just going to work. And I'll tell you that, probably, but it is a new runtime. This is, you are moving from .NET Framework to .NET Core, and there may be some behavioral changes. The only way to really test it is by executing every single code path in your application. If you have a menu option, do it. File, command, right-click, whatever. Run through it. You'll probably be fine, but there may be some edge cases. And there is a page on the docs site that lists some of the known breaking changes between them. For example, if you're doing process.start to launch a document or launch an executable, there is a default change there. May not matter, but if you're trying to launch the default web browser, you need to be aware of how to make that small change. And it is documented, but executing the code is important. Did I mention test? Also, while you're doing that, may not be a bad time to start looking at automating some of your UI tests with things like WinAppDriver, where you can incorporate those tests that you're busy doing into CI and CD. So never a time like the present to do that. And if you do want to consider self-contained, that is, I want to include the framework with my application, just be aware that there is a risk that you're taking and assuming for yourself in the patching and updating for security vulnerabilities. If you have a shared runtime on the machine, Microsoft or your IT department will patch that for you and get that so that if you have some monthly security release, it will be out there and your application will take it. If everything is in your publish directory or your single executable, that's like the same as if you had a static library in C. Everything is in your application. It's not pulling anything from anywhere else. And it's on you to rebuild with the newer patched SDK and redistribute that to your users. So if you have CI and CD set up, that's not as much of a big deal, long as you have the process in place to do it. So again, I'm not trying to scare you away from doing this, but it's something you should be aware of. And there's a long blog post written by one of the .NET Core PMs, she's in the back of the room there, on how to migrate your application to .NET Core 3. So please check that out. And if you have any questions, we'll be happy to answer them moving forward. We really want you to be on .NET Core 3 and succeed on it. So let's take a look at how we can migrate our app to .NET Core. So let me switch back here to the other machine here. And what we're going to do is start by looking at the application in Visual Studio. And I'm going to check to see if I can see the project file, because I don't necessarily know if this has been migrated or not. And in the new project system, I can much more easily edit the code. And that's probably just a quick and easy way to check if you're not sure. So if I right-click this, I'm scanning the list, and I don't see anything here that says, say, edit this project file. That's a pretty good giveaway or good clue. If I unload the project, now I can hit edit. If that's how you have to edit the project file, you're on the old project system. Another giveaway, when you do open it, it kind of makes your eyes bleed a bit. There's a lot in here. Most of it's not needed. It's a lot of gunk. So we're going to make this go away. So I'm going to just reload that. And I could do this while Visual Studio is running or the solution's open, but I'm just going to not. And I'm going to come up to my command line and run here the try convert tool. I've already installed it just to save the time. And I can run try convert. This is installed as a .NET Core global tool, so that's available on NuGet. I run the command that was on the slide, .NET tool install, blah, blah, blah. It puts that available in my path for me to use. So I'm going to pass it with the -w switch. And that's just going to tell it which is the working directory that it should look at. And in this case, I'm already in my solution directory. So I'm just going to say this one. And it's going to take a pass-through and tell me that it was complete. So let me come back over to reopen the solution. It starts off by looking the same. However, if I look here at the project file, edit, the edit button is there, so I know that it has been moved over. There's a few things left that it didn't get rid of, and that's because I had the ClickOnce publish information in here. We're going to nuke that too, because we're going to get rid of ClickOnce in a moment. So I'm going to just get rid of all of this. OK, we don't need that. So you may have to do a little bit of cleanup on your own, depending on what you had in your project file. I mean, it's a best effort, but it'll get you, say, 90% of the way there. There's also ways you can simplify this even further with asterisks and wildcards and such, but we'll save that for later. And you can see there's other like ClickOnce bits in there that you can delete. If I look at the class library, I can see that it has moved this over to the new project format, but it has not yet touched the target framework. And that's because it doesn't want to make an assumption that if you want to target .NET Standard or .NET Core. So in this case, we're just going to switch this over to .NET Core app 3.0. And at this point, we should be good to go. So if I hit compile, and it's just going to build this, and I can see that, hey, there's an error. I used the registry. There was no problem on .NET Framework. Do I have a problem here? Well, fortunately, the answer is no. There is a compatibility pack that has virtually all this API surface area you need. And if we come to manage NuGet packages, we can come on in, and I can say, Windows compatibility. Install browse, yes. Someone ought to fix the default somewhere. Imagine that. I think we should take some notes here. So yes, I'm going to come in, install all this, and it's going to pull in a whole bunch of different compatibility packs. This can be further trimmed, because there is one specifically for the registry. There's one specifically for printing and drawing. So this is the easiest one to use if you just say, hey, let me start here, and I can peel this down further if I want, just to reduce the overall size. And now, at this point, I should be able to build this, and it'll run just fine. Oh, what did it say? Contoso is not a valid entry point. Oh. Let me just do a rebuild. I think I got confused. Rebuild. Probably got confused by having the old DLL in there.
You've got the DLL set as your startup application.
That's true. Let me try that. Set a startup. It's going to run this time. And it does not. Why is it set as this? Publish is not a valid entry point. No, the .NET Core 3 projects are DLLs. But let me just try this one more time. Start an object. I shouldn't have to set this. That should be defaulted. And it does not like that. I'm going to just cheat, because we're going to move forward. So I'm going to switch over to here, where I can say the magic of the demos, where I can reset hard to my commit that works, hit reload everything, and rebuild. And I'll be really sorely disappointed if this does not work. Here we go. Good. Done. And it pulls up the application pretty much as you would expect, because all we did is switch the runtime. And if I pull up Claire, we can see that the expense we added before is in here, this steak dinner that we had last night. And we get things like hot reload if we want to start messing around with the XAML designer. All right, so now I can also then, if I want to get to this self-contained publish and say, hey, how do I get this out to my users? I can come up and hit a publish target, say I'm going to pick a folder, create profile, and if I see the buttons here, here we go. Come on. Plus, thank you. Release and target framework allow me to edit the options, and that's how I can set the properties there. So if I come in and I say edit, I can pick here, is this framework dependent, i.e. the runtime already has to be there, or do I pick self-contained, that everything's going to be in the output? And if I pick self-contained, I do have to specify which runtime it's going to be on. Is this x86, x64, ARM, et cetera? And this is also where I get the options to say, is this going to produce a single file, that exe, and do I want to pre-JIT some of the stuff that's called ready to run? It'll do some kind of optimizations. And in preview, that'll do some of the assembly trimming. Again, your application's more likely to break without additional tuning. If you turn that, that's why it's in preview. It's not just self-explanatory. It's not good enough to just work automatically yet. We're getting there. So with that, I'm going to switch back to the slides. All right. OK, so we've looked at how we get you to .NET Core 3, but I don't want you to come back from here and tell your bosses, or your bosses are going to say, hey, what did you do to my framework? Are you forcing me to spend more money? That's not cool. And I want to say that .NET Framework is not going anywhere. .NET 4.8 is the last version of .NET Framework. However, it is and will be supported for a very long time. It is a component that is shipped in Windows, and Windows has a very long support policy. I mean, Windows 7 was just supported until, say, 2 weeks ago. And it was about, it came out in, what, 2005 or so? So, it has a very long support window. It will be patched. It will get updates for critical things. If you have an application that is, barely touched, it's saying once or twice a year, we need to tweak it, it's not worth the effort. Keep it on .NET Framework. I'm not gonna, there's no value you can add to moving this thing forward and spending the time to move it. We do recommend starting with .NET Core for all new applications. If you're doing file new project and saying, I need a new thing, please do that on .NET Core. I mean, you'll be better off in the long run that way. And if you're having an application or you're working on an application that is just under active development, so you're adding new features and this is just part of your day-to-day, run the business, I would look at that and look at moving that over as well. So you can, that's kind of where I would draw the line, is if it's a barely touched, not worth the effort, leave it on .NET Framework. If it's just part of the day-to-day application that you're actively developing, it's a pretty good time to start looking, and we can try and help you get over to the modern framework. Modern applications do need a new way, or modern way, of getting applications distributed. Previously, there were multiple ways you could deploy to a client. There is ClickOnce that we saw before, many of you are using. There's MSI files. There's Squirrel. There's Xcopy. There's a number of different ways. Each of them have some pros and cons. But MSIX is a new packaging format that Microsoft put together a few years ago. It is open source. It is developed on GitHub by the Windows team. And it has a number of benefits, including doing things like keeping all your applications together so they can be uninstalled cleanly. So when you install an MSIX package, it puts it all into a container of sorts. Windows actually has 4 different kinds of containers that run on it. This is one of the container types, where it virtualizes access to certain things. So if your application needs to write to the registry or write to certain areas of the file system, it can continue to do that, but it's going to be redirected to an area within the installed directory of the application so that if it gets uninstalled, it's completely clean. How many folks here have installed iTunes on Windows? OK. How many folks have tried to uninstall iTunes on Windows? Yeah, it's going to ask, did you succeed? So iTunes is actually in the Windows Store, Microsoft Store, as an MSIX package. And that is the only way I have it installed, because I know at that point it can be uninstalled cleanly. So definitely, there's a lot of advantages. Also, from a practical level, it does things like block level delta updates. So if you are working with areas with poor internet connectivity, or where you're measured by the byte or by the just satellite offices, and you need to get an update to your 100 meg application out, if you haven't changed the framework, it's just some application code, the delta between them is probably pretty small. You don't have to think about this. You publish the update, and the update mechanisms, the tooling, does this for you and calculates the differences and only transfers what's needed. Windows also has built-in tooling for doing the automatic updates, so you don't have to write that or handle it yourself. And you have a lot of control over that. So, MSIX can be used to deploy any Windows application. It is not tied to UWP. It can be used for MFC applications, console apps, .NET Framework. That's something you can use today, even if you're not moving over to .NET Core. It can be published pretty much anywhere. There's a common thought or misconception that, hey, if I use MSIX, I have to use the Microsoft Store. And that's not true anymore. It used to be when it first came out. But you can publish to a network share, to an Azure Blob storage, to any location that you want. And there are mechanisms that Windows has to automatically update that. So you are in full control of that. And if you're using things like SCCM or Intune, it can push and distribute those out as well. So you're in control. It supports both of the .NET Core 3 deployment modes, so it works with either framework-dependent ones or self-contained. It's actually a great way to deploy self-contained applications, because everything you need from the runtime is all in the MSIX package. It doesn't pollute anything. And quite frankly, your end user doesn't know or care how your application is running. They launch the app, it runs, and you, the developer, are in control over what's in it. And short version, it is the new ClickOnce for 85% of the cases that ClickOnce supports. So definitely, if you're using ClickOnce today, take a look at MSIX, and we will explore that further in a minute. There is an XML file that you can use to update and control how the frequencies are done. And there are things like automatic background checks to say, hey, look, is this being automatically updated in the background? Does it happen on launch? How often? Does it have to update before the application starts? There's documentation of this online, but you are in control of it, and you have ways to configure it. So we have an application that we've added the packaging project, and we want to build it. We have two current ways to do that today. First is with Azure Pipelines, and then they have the new one to the field is GitHub Actions, which has been making a lot of noise lately. They have some similarities and some differences. Azure Pipelines is free for public projects. So if you want to say, hey, this is pretty cool, I want to check this out, I have an open source project, you can use Azure Pipelines at no charge. It supports GUI-based editors. So if you're saying, hey, I'm not really comfortable with that whole YAML bit, because it can be a lot of overhead to learn what goes where, and it's hard. I have to look things up all the time, and I say, look, what's the parameter for this? What's that? GUI, it's there. I can drag and drop, fit a button, and mouse over, get a tooltip, and see what I need to do. Pipelines is full-featured. It supports things like code coverage, displays all the test results, analysis, reporting. There's a lot of stuff that Pipelines does. It also is very tightly integrated with the release management capabilities. So you can decide, hey, I built the thing. Now I need to get it out. And there's a whole separate set of tasks and processes that DevOps has that is quite good at that. It's also really good if you are deploying something to Azure. It has tight environment. So you need, hey, I need to access this Azure resource. You can push this button, and it will set stuff up behind the scenes for you to save you a lot of head banging. Actions is also free for public projects. For private projects, both of them do have a cost. It is reliant on YAML-based build definitions today. And it's still fairly young. A lot of things in there are in progress, are going to be worked on, are coming. So that's another way of saying that it does not currently display unit test results or code coverage. You can still fail your build. But if you just want a nice report of what passed, what failed, and all this, it's not there today. It does have a large ecosystem of build actions, though, and that's one of the it is pretty cool because anybody on GitHub can write an action, a set of functionality that you can reuse in your build, and you just point to it by using, kind of point to the repo that contains the action. So it's going to grow, and there's already a large ecosystem of these, and it's only going to get larger. So my personal recommendation today, and I use pipelines for all of my projects, but I'm keeping a close eye on GitHub Actions towards the future, especially as it grows and develops more. Branching is an area that we often don't really think a lot about, especially as desktop developers, but it does have relevance here, in my opinion, because as we're starting to do CI and CD, we need a cohesive and easy way of getting these things deployed out to your environments. And if I have too many branches, like, hey, am I building off of this branch, or what's going on in this branch, or what's versioned to what? An important aspect of CI and CD in particular are versioning. Because if I have a mechanism that needs to update from one build to the next, then it's really important that that build number be higher, or higher within that branch or something, right? There needs to be a way, and no one wants to do this manually. So we recommend using a trunk-based development flow. This is like sometimes it's called GitHub flow. Some people call it release flow. And this is where you typically have a master branch that is always production ready or close to shipping to production. And you use topic or feature branches for work focused on those things, like new feature, new this, new that, fix a bug, create a branch for that. Use a pull request to review the code and get that into your target branch. And when that pull request hopefully triggers a build so that you can validate that everything meets your needs, you merge it in there. And at some point, you decide, hey, look, this is getting close to stabilization. We want to get it ready for shipping. You would cut a release branch at that point. It's important to note, though, that release branches are never, ever merged back into master. At that point, it really is stabilization. If you need to put final branding on, remove pre-release tags or whatnot, that would happen in your release branch. And if there is a bug that happens, that's where you could, in production or in that production branch, you could merge it into both. Or you cherry pick you do it in one branch and then cherry pick the change back into master to make sure that you aren't losing track of that moving forward. But we never merge the release branches back into master once they're cut. The other thing, so there's a library that one of the community members has called nerdbank.getversioning that can handle a lot of these automatic versioning needs for you. There's a few of these tools out there. This is the one I like, and I use in all my projects. And it calculates the version based on a version.json file that you check into your repository, plus then the height of the history since the last time you've incremented the number. Basically means I can set it and forget it until I need to change the version, change the major or minor version, and I get continuous versions and all that I can use in my build from there on in. So let's take a look at the stuff, some of the packaging project and things we just talked about. So if I come in here, let's go add a packaging project, and I'm going to cheat, and I'm going to say, we're adding a packaging project, so you don't have to see me hit, file new project and, fumble through some dialogues. But I have a packaging project, and I've added an application. And what I can do here now is come in and look at things like the manifest. The manifest will contain things where you can set your icons, your descriptions. If you've ever looked at the UWP tooling, this is going to be very familiar because it's the same underlying project type. But like I said before, it works with any. It's not tied to UWP at all. It's just the container. I can add in icons, and you can generate them in. You can tell it things like here we go, file type extension. This is the useful one. So one annoying thing that many installers have to do is register their file types. So you can double-click the file. This is something you get mostly for free or declaratively by using a packaging project, because I can come in and I can say this is foobar file type. Give it an icon if you want, foobar. And I can go ahead and say, .foobar. Here we go. Oh, didn't like that. Oh, because I added a new one. There we go. And I can move on. And when this installs or uninstalls, it adds the file type association for me. So I don't have to remember to clean that up either. So again, it's very declarative in nature, and all the other things you might need, whether it's a protocol handler or other permissions that you might need, are in here. Typically, for desktop applications, you don't have to worry too much about permissions. Everything runs as full trust. That was one of those things that was a source of friction for UWP projects. So know it's there if you want to use it, but for the most part, everything runs as full trust. But you can take advantage of the declarative aspects of that. Now, I'm going to switch over here to the pipeline YAML. So all of this here is available on GitHub, and I have links to the repositories. I have 2 different demo repositories. I have the one we're using today, and I have a link to another similar repository that has a multi-channel, more complex pipeline that might be a good starting point depending on what your scenario is. I know that when I'm looking to start a new project, I rarely want to write a YAML file from scratch. I probably want to say, hey, look, let me find one that does most of what I need and tweak it a little bit. So I put these out here for you to use as that kind of starting point. So to walk through that a little bit, we need, this is Azure Pipelines. So we can declare both a trigger that works on CI builds, just pushes to a branch, and PR triggers for things that work on pull requests. And I can specify here which branches that might apply to. In this case, I use a convention called rel/star, so rel for my release branches. So I may not want a CI build to any ordinary development branch if I'm using like my team. I don't need them doing a CI build on every commit. But when they do a pull request to master, I want that to be there. And that's where I can define those. I can specify what VM image I want to use, and this can be Windows latest. There's also Mac OS and Linux pools available. So if you're doing multi-platform builds or you're doing Xamarin work, you don't need to have your own Mac build farm for this. We have all that for you. This one is a kind of a useful one, kind of a little build hack, and it'll save you a minute or 2 off your builds. So the continuous integration machines on Azure Pipelines use a new image for every single build. And that's for security reasons. You wouldn't want to have a pull request run and potentially install code that potentially malicious that you would then infect your build agent, which could impact your production releases. So we give you a new clean image each time, which is great. But .NET Core has this feature where it tries to pre-cache some images, some data for you on the first time you run it. That's normally great if you're doing things at home, but on a machine, when you're going to run it, new machine each time, it's a pointless optimization. So you can set this flag there to disable that experience, and it won't pre-cache stuff for you, and shave your builds off and make it a little faster. And all of these steps here are available as GUI steps in the editor as well. I'm kind of going over the YAML here, but this is equal parity on both sides. We can specify which version of .NET Core to use. The thing to note here is that I don't have to give it an exact version. I can say 3.1.x or 3.x if I'm brave and I want to use the latest non-patch release. But what this lets me do is handle those security updates, where I can say, I'm using the 3.1 SDK, but I'm using the latest 3.1 SDK on every build. I don't have to remember to say, is it 3.1.100, 3.1.102, 103? And I don't need to worry about that. I have other better things to go do. So Wildcards are your friend and can keep you secure by being on the latest version. Then I'm going to install the nerdbank.git versioning tool. This is a way we can install global tools within the context of a build. And I'm going to invoke it on the next step. What that does is it sets a number of variables within the build, including the build number, so that we can see that the build number matches the version that we're doing. So everything kind of lines up for you. Finally, because we need to automatically update the manifest file. So like nerdbank git versioning, by virtue of it being there and being referenced in the properties as a NuGet reference, it will take care of setting your assembly version. It will set your all the NuGet versions and all that good stuff for you. It doesn't yet support updating the AppX metadata, the version that goes into that packaging project. So we use a little bit of PowerShell to do that, because PowerShell makes it easier to work with XML. I mean, here I don't need to do any parsing. I use this magic XML bracket, and then I can just dot into the part of the document I want, and I set that to the variable. And that variable is there because we called it earlier. Then finally, we do our restore and build. So we restore the project so it downloads all the NuGet packages. And then here I'm specifying where to put the MSIX package. And I realized that it says AppX package directory, and that's just because that's what it was called before. And some things, variables, are hard to rename. We don't want to break you. And then the last step is, well, we built the package, publish it as an artifact so that the pipeline or release pipeline can use it. And again, we can do that. So this is, I think, a fairly minimal one. There's some steps in here, but if you're looking for a starting point for your application, this is definitely something to use. And if you have feedback or suggestions, always looking to see how we can further improve and streamline the builds. And please ping me offline, and happy to go over that. So once we have it built, this is where we would then go into a release pipeline. And this is an example of a release environment where this is one that I use for a package called NuGet Package Explorer, which is an open source tool that is used to view and edit NuGet packages. So in this is an desktop application. It's using packaging projects and all that. It automatically goes into a CI environment where then I have multiple stages to decide, is it going to the Windows Store? Is it going to Chocolatey? Or is it going to release on GitHub? And you can define manual approvals to say, look, it's automatically going to go to the CI feed, but then only certain builds are going to go to the store. And there's more documentation on how to set this stuff up as well. So this is the kind of thing you can do with CI/CD. I swear I'm not going to cough like I did last year. All right, so telemetry. Telemetry is that thing that, how many folks here are collecting telemetry in your app? Desktop apps, let me be more specific. A few, OK. That's about what I expected. Telemetry is a thing that web applications have been collecting for a very long time. And it's just because a lot of the tracking SDKs and things they've been adding, part of adding your Google Analytics, right? You want to track your data so we can figure out what you need from marketing, what's working, maybe sell some ads, maybe just figuring out all that. It does a lot just by adding in one line of JavaScript. And desktop applications haven't typically had that same luxury. So telemetry is important, though, for modern applications. And that's because modern applications tend to be, or the modern ways of approaching application development are data-driven. We need data to know what parts of our application are we using. Are people discovering that new feature? Did you put something in there that nobody's using? Maybe if nobody's clicking that menu option that you thought was super cool, you need to inform users about it. Maybe you put one of those yellow bars that people love to hate, but it tells you that that feature's there. but you need to be able to have the data to make those decisions. It can assist in determining what led to a crash. And a lot of people think of telemetry as just crash dumps. I'd say that's certainly super important, but there's more to telemetry than just crash dumps. So it's the crash dumps and collecting the other data. We need to make a decision here. And for that, I'm going to just jump into the telemetry for NuGet Package Explorer, because while I could put this in a demo app, I don't think that would be as useful, because everybody, you can click a button here and there, and I can show you an event. But in order to see the kinds of stuff you can get, NuGet Package Explorer this is just in the last 14 days, it's been opened 40,000 times, and it's, I think, easier to kind of get a sense of this. And I urge you to consider what kinds of data you might find useful for your own application, because you can enrich what comes out of the box with any custom properties you might want to send. In this case, what I can see is that NuGet Package Explorer has been used 27,000, and more users from the store. This is broken apart by channel because I collect the data. I can see that which countries people are coming from, potentially what versions of Windows people are using, as well as what version of the application they're on. So if, even though this is for the most part automatically updating, certain channels update better than others. Chocolatey is great, but it doesn't currently have an automatic update mechanism. Someone has to go in and say, update my chocolatey packages. So that if I look and I slice and dice this, I can see that the chocolatey ones tend to not be as always up to date. I can also come in and look at the user flows. And the user flows will come in here and show me how the users are navigating through your application. This does take a few seconds to load. But again, it's the kind of thing that web applications have had for a long time. You click on a page, you go to the next page. And this is a very visual way of seeing you can do this same thing in your desktop application, where I can see that most people start at the main window and click View Existing Package. Not really surprising. Most people use this tool in view mode. But and then when they do, they trace it through, and then they session ended. They exit the application. But then there are others that come into the package chooser dialog. And that's where they want to view, say, hey, I want to search for a package and view it. And you get the idea. You can follow this through your application. Oh, and by the way, in any of these, I can cross-reference into a crash dump. So if it does crash, I can see the breadcrumbs. I can see the steps and see what the user did and try and help narrow down what led to that crash and reduce that time to find it. And then there's other useful bits here. If I come in and just view the, where'd it go? Usage by hours of the day calendar, I can see that this application is pretty much used 9 to 5 on weekdays. And that tells me that while there are some people that use it in their hobby projects, most people are using this application for business. And there's nothing like a chart here to pretty clearly lay this out. I didn't have to do any of this work. I'm not a data scientist. I didn't author this report. This was out of the box. So, you can use this to understand and make better decisions in your application about who your audience is and so forth. All right, switch out of that. OK, so talked about CI/CD. We talked about telemetry. And now we're like, hey, let's get to the modern part. This is a modernization talk, right? So let's talk about it. There's a couple of different techniques, one of which is called Zamel Islands. How many folks here have heard of Zamel Islands? OK. Talked a little bit about it last year. It's been in flight for a while. It had some rough edges to get it right. Still in progress. But it's a way of embedding a UWP control into your existing application using WPF or Windows Forms. And that's to say, there's things like the Bing Maps control, there's the modern text boxes, calendar controls. Any of those controls you can put in there, and it uses a technology called Zamel Islands to do it. It's a little clunky, but it works, and we'll look at a demo here that shows how we use Zamel Islands in a minute. At Ignite, we announced WinUI 3. WinUI 3 is the separation of the Zamel Islands, those controls, from the underlying Windows operating system. One of the limitations in the past of the current Zamel Islands approach is that it relies on the controls being in the version of Windows. So Windows itself releases every 6 months or so, twice a year, something like that. But you start running into that challenge of, well, what if your users are using a version of Windows that's a year or year and a half old? Can I use that control? And yes, there are techniques in there for falling back and doing partial things. But again, that gets ugly, and it's not reliable. And it's probably harder than you would want to do. WinUI 3 is now being developed open source. It's C++, so it is not C# or .NET. But it can be used from C# and .NET, or really anywhere. It's being developed on GitHub in the open and supports all versions of Windows 10. It is decoupled from the operating system. So all versions of Windows 10 can use this library. So you can use this and hit the wrong button. Put this in your application. And it works with any of the existing Windows technology types. WPF, WinForms, no application model is required. And the team has a detailed roadmap on GitHub where they dive into their timeframes. And I expect to hear a lot more about this over the coming year. So let's take a look at how we can add the calendar control into our application. Because we saw before at the beginning, we added a new expense. And we got this kind of nasty checkbox. But if we're doing things, if anyone's using it on a Surface, or maybe you need an accessibility issue, the modern Windows calendar is a lot friendlier, a lot cleaner. So I'm going to come in here, and I'm going to cheat a little bit. I'm going to continue. I'm going to say git reset to tag 4. Again, all of this is on the repository, so you can kind of follow along and see what was added at each part. But I'm going to focus in here is, yes. Do I want to reload the new file? Yeah, that's fine. If I come in, let me just make sure it's cleanly built. OK, come on. Good. OK. I have come in, and I look at my views. And I'm going to look at my add new expense dialog. And first of all, I can see we're still on .NET Core 3. The designers work. I mean, they've been working for a while. So if you were ever scared or saying, look, my designer's not there yet, they're here. We get full parity. In fact, there's stuff that it can do here that we just announced for the latest preview with some added actions. More investments coming into the designer. So we're moving forward. I've added in here a spot for, let's make this bigger, this Zamel element host. And I'm going to make that bigger. 200%. A little bit big. We'll get through it. I can add in the Zamel element host here. And I give it a type name to say, hey, I want to instantiate a calendar. Oh, where'd it go? So it happens when it's too big. Losing it. I'll go this way. All right. So we have the initial type name. And this is we're saying, hey, this is the out of the box. This is the calendar control. There's nothing special here, except we can't new it up directly because it needs that interop layer of the Zamel host to do it. WinUI 3 will make this a lot better, so you don't have to do this. For now, this is just the way you can go forward. But we can data bind to it a little bit. We do need to do a little bit more work to do that. So we're going to give it a name, calendar UWP. And we're going to then give it an event, child changed. And if I come back in here into the code behind for it, I come back to Solution Explorer, check out the code behind. Here, let me make this 150 slightly bigger. Because I can't reference it directly in Zamel, what I can do is say, as the Zamel is constructing its element tree, let me know when you've constructed the calendar control instance, and then I can hook up my own events to it. And this is where we can do our data binding. So I can come in here, I get an instance of the Zamel control host, I get its child, and then cast that to the correct type, that I've put in there. This is the calendar view. And now I have a calendar view object, the instance of it in there, and we can hook up to the events and manipulate it and do whatever we need. Again, this is what we can do today when UI3 makes it better. But we do get, we can data bind this back, and we can say, look, I'm going to send the selected, the date message over across our app's messaging bus, which will show up then, within the app. So if I build this here and run it, I can come up and let's do the same thing. Let's just come in, hit add new expense. And in its place, we have here, here we go. We can view the calendar date. And I think the resolution's cutting this thing off. But we have access to the full calendar control, which is a friendlier control. But there is a label here at the bottom when you run this at home where you'll see that the dates are updating as it changes. I'm going to update this and put higher up because that's what happens when you demo. 1080p, right? Our machines are all high res, and then we get to a screen where it's not so hot. But this is much more touch friendly. It has all the effects, and it is data bindable with that little bit of code behind to do it. All right. So Visual Studio 16.4 for 2019 has all the tooling already that you need for everything that we've talked about here. It had some support for the new certificate management. We didn't really talk about certificates or code signing. You don't have to worry about it too much if you're doing local development. We removed that as a need. It's never really required. Now we've made the tooling not give you certificates that you don't need. But if you publish stuff, there's some better dialogues in there. And there's support for those app installer templates that we talked about, which give you that flexibility for how you want to do your updates. A couple of calls to action here. Please use some CI and CD of some sort. Pick your one, or if you want to do another one, pick whichever your favorite is, but do it, please. Look into using a packaging project for deploying your application. It is the future. It's where things are going. And it can work with your .NET Framework application today. You don't have to wait to move this to core to do it. In fact, once you do move to core, your users won't know the difference. Quick short story. NuGet Package Explorer was a .NET Framework application when it started. It was deployed with MSIX to the Windows Store back a year ago, November. This was in 2018, back when .NET Core 3 was in its early alpha days. This was before they released Preview 1. I was playing with the nightly builds, and I got this onto everyone's machine. It didn't matter because it was self-contained. I was like, look, I'm an early adopter. I like this stuff. And I made a self-contained app. I ported it to .NET Core 3, and nobody knew the difference. And I don't feel at all bad about it either because I wasn't polluting anyone's machine with beta or preview bits. It was basically, if the app crashed and users were mad at me, then it's my fault. But I can own that. So instrument your applications to start getting that telemetry, and maybe look to see what WinUI controls make sense. Now, I'm going to leave this slide up for a moment, just so you can take some pictures. But these are some of the resources we kind of looked into. There's the sample app that we've been looking at, along with the DevOps demo and a couple of additional pipelines, and then some additional links here. And with that, I think we're just about out of time, but I can take a question or two, and I'll be around for a few minutes after, and like I said, on Twitter or anything today. So thank you very much. Yes, sir.
I had a question about the WinForms designer.
WinForms designer, yep.
When's that coming?
So we have Alia, who is the PM for the WinForms designer right here, and we can have her answer the question.
Yeah, sure. Thanks for the question. That was a great question. So we're working on it right now, and it's already available in preview, in Visual Studio previews. And we covered controls-based scenarios. What is not there is custom controls, third-party controls, and data scenarios. We're working on it, and we're planning to get a solid version around May this year. and we're hoping to be done completely by .NET 5 in November.
Thank you, Alia.
Thank you.
Yes, in the back?
Is it possible to bootstrap an MSIX package?
Is it possible to bootstrap an MSIX package?
Yeah, like to install drivers?
To install drivers. So drivers are not currently supported for MSIX today. I know that they are working on filling in a lot of those gaps. And I expect to hear more about that, again, over the next year. It is the direction. I know they're working on making sure that all scenarios are supported that way. Things that require like that level aren't there. They are also looking at supporting services. I don't recall whether services are currently supported today or not, but Windows services are definitely in the target and scope for MSIX. I will add that services are supported with .NET Core 3. So if you need a Windows service and you want to do that, there is some service package base frame, there's some package you can add for it that is actually pretty cool because it supports cross-platform services. So it works as a service on Windows or as a daemon on Linux. So you don't have to worry about interfacing with the operating system. So service type of applications are fully supported with .NET Core 3. OK? Well, again, thank you very much. And please feel free to reach out to me on Twitter with any questions or see me sometime later today or tomorrow.